webinar is focused on the state of the systems that are in public service. And our speakers today include Robert Lohman, Chief Operating Officer for To Get There. He was a co-founder of the business and is responsible for business development. He's also a board member of the ATRA industry group. I'm Peter Muller, President of PRT Consulting, also President of the Advanced Transit Association. Today I'm presenting information on the ULTra global system. I would like to emphasize that I do not represent that company and am just presenting their information. Finally, we have Fernando Mijares with Modutram. He's a co-founder of the company and responsible for business development. So to tell you a little bit about what automated transit networks are, they involve driverless transit. Everything we're going to discuss today is automated with no drivers. These systems include a fleet of smaller vehicles, typically carrying anywhere from 2 up to 20 or 30 passengers. Stations are offline, allowing non-stop travel to the destination, as indicated in the illustrations on the right. The systems operate on demand. There is no schedule. They're just there when you need them. So some of the systems that are in public operation today include the ones shown in the picture, and we're going to focus on the three in the middle of the picture. To Get There, Masdar system in the middle at the top, the Rivium system at the bottom left, and the ULTra system in the middle of the picture. We're also going to hear from Modutram, which has a demonstration system. They're not quite in public operation yet. So with that, I'm going to hand over to Robert Lohman with To Get There.
Thank you, Peter, and well, good morning, good afternoon, good night for everybody online. I'll be running through our existing projects and giving a view of a new project that we signed an MOU for in January, and the development of our third generation group rapid transit vehicle, which is currently ongoing. For To Get There, it started back in 1997 and 1999 with two pilot projects in the Netherlands. And in 2006, we were able to realize the second generation group rapid transit system at Rivium in the Netherlands. And as you can see from the picture in your image, it's quite unique in the sense that it operates at grade and it has at grade intersections. This system has now been running well, almost 10 years. Which means that an extension of the operations contract for the public transport operation company Connection is due next year. And now they're actively looking into an extension of that contract and some remedial work on the infrastructure, which after 15 years of continuous driving in the same position is due for a little bit of remedial work. Uptime of the system is usually better than 99%. And has been constant over those years, which is mainly in line with what is being achieved at Masdar. The Masdar City project is well, probably one of the better known PRT projects that has been realized over the past few years. We're now into the 5th year of operations, and as you can see from the image on the screen, especially the blue line, which is the number of passengers per month, and the red line is the number of trips per month, there is still growth in the number of people that we are welcoming every month. The system availability has continuously been better than 99%, and for the last 6 months has continuously exceeded 99.9%, with the last couple of months coming in at 99.96 and 99.99. So we're quite proud of the achievement we're able to realize at Masdar. The experiences of both the GRC system at Rivium and the PRT system at Masdar have been used to go out to market and market new applications. One of those new applications is Hsinchu City in Taiwan. This is a connection between a rail station on the left-hand side of your screen and a high-speed rail station on the right-hand side of your screen, and a major university and a major science park in between. The total distance of the connection is about 6 kilometers, and the total number of people to be transported through this network in the peak hour is about 4,800 passengers. What we've done in this application to minimize the fleet size relative to the capacity being achieved and to maximize the frequency and the trip times is go for different connections within the network. So what you see here is a connection between the high-speed rail station and the Hsinchu Science Park, and that has a service frequency of once every 3.5 minutes. Similarly, there's a connection between the rail station and the high-speed rail station, basically both serving the university complex that's located in between, and that has a frequency of one vehicle departing every 1.5 minutes. There's also a connection from the rail station to the science park, serving all the stations in between, that has a frequency of every 2 minutes. So that means that if you're going to the university, you can actually use the yellow or the red line, with the yellow line having a frequency of once every 1.5 minutes and the red having a frequency of once every 2 minutes. So they're more frequent than that even. Finally, because there's such a strong link between this rail station and the Hsinchu Science Park, is that we've actually introduced an express line, and the express line basically bypasses all the intermediate stations and creates a direct connection between these stations. For the simple reason that the number of people traveling between these two stations is so large that a dedicated connection is warranted. In total, there's over 4,800 passengers per hour being transported in the network, with different frequencies on different lines depending on the capacities that are required on those lines. What I would like to show you also is that there was a impression created how this system would look like in the eventual application. So depending on your download speed, you should be able to see this fine. We did test it beforehand, so I am going to play it for you now. And by the time it finishes, for most people, we'll go back to the presentation. Okay, I hope you view that without any stuttering of the video, so that was nice and smooth. And we'll continue the presentation from here. The vehicle that you saw in the video is our third generation group rapid transit vehicle. And you see it displayed in the pictures here. And we developed this to be more of a similar phase to the PRT vehicle at Masdar. So relative to the second generation vehicle, you see that the wheels are now constructed within the body to make sure that it looks, well, more futuristic. And we are still using as much, well, glass as possible to allow people to really easily look in and out of the vehicle, creating the sense of belonging within the environment. On the interior, there are different configuration possibilities of the seating. What you see here is a standard configuration with 8 seats, with the middle floor available to standees completely, thus optimizing the capacity per vehicle. If needed, additionally 2 to 4 seats could be located in the center additionally. What we do have to take into account is that that is also the space where the wheelchairs will be located, and that we have doors on both sides of the vehicle able to open to the stations located on either side. What is new and what we're announcing today is actually the design specs that are foreseen for the system. So what we are doing with this new generation GRT vehicle is that we're creating a vehicle with all-wheel steering. The all-wheel steering allows us for greater control over the vehicle on the guideway, so that when you're going through a curve, the curve can be kept more narrow relative to what we have in the second generation. It also allows us to create a completely bidirectional vehicle. So that means that we will no longer need the turning loops like we have now in our first generation, but that we're able to stop and go backwards. A feature that is very typical in APM systems, but that we're now also introducing on these vehicles, making them even more suited for pinched loop applications. The vehicle being bidirectional also introduces the need for doors on both sides. So the fact that that was taken into account in the design is not a coincidence. Furthermore, for our sake, we are transitioning from the 96 volt system that we have now to a 400 volt system. The main reason for this is that 400 volts seems to be the emerging standard for electric cars, and any components that are manufactured for cars are manufactured in such quantities that the prices are steeply dropping. And to take advantage of those lower costs and have easy access to those kind of components without the need to develop special components that would be able to run on 96 volts, we've decided to move towards the 400 volt system as well. It also allows us to integrate the latest battery technology that's also being developed for these type of cars, with the vision of having the vehicles available for a larger percentage of the time, so less recharging or quicker recharging, and being able to accommodate a higher top speed. It's the vision that the new top speed, where previously that was at 40 kilometers per hour, for the next generation should be at least 60 kilometers per hour. Our approach to the design engineering is that we'll do all the engineering for the vehicle in the Netherlands. That will deliver us a standard package, and the standard package can be sent to different manufacturers to manufacture the vehicle. So that could be done in the Netherlands or even locally, depending on a local firm being available that has the competencies to use the design package to actually transfer it into an actual vehicle. That concludes my presentation, and with that part I hand over to Peter, who's presenting.
Thank you, Robert. Yes, again, I would like to emphasize that we're an independent consulting firm. We do not represent Ultra Global in any way. Unfortunately, they were not able to present their information, and so I've been given the task of doing that. What I'm going to do is focus on the Heathrow application, give you a summary of where they're at, talk about the passenger benefits, the benefits to the airport itself, also future developments that are planned for the airport, and then I'll wrap up with a brief discussion of some other opportunities that ULTra is pursuing. So the Heathrow pod connects Terminal 5 with the Terminal 5 business parking lot, and unfortunately this is a version of this slide deck that has an error in this bullet, and was corrected but then got uncorrected again. So the system has 21 vehicles, 3 stations, and about 2.5 miles or nearly 4 kilometers of one-way guideway. This guideway is quite intricate. It crosses 7 roads and 2 rivers, and then it has to go under the approach surfaces to the runway. So it's approximately 80% at grade, 80% elevated and 20% at grade. So far, the system has carried over 1 million passengers and has done nearly 3 million driverless miles with some 26,000 hours of operation. Passengers love it. Heathrow does a great job of interviewing its passengers and asking them how they feel about its various systems. Ever since the system was implemented, it has ranked higher than any other system at Heathrow. Mostly the passengers like the predictable journey. When they get there, they're met by a vehicle in the station, at least 80% of them are. Others wait a few seconds. The average wait is around about 20 or 30 seconds. So they like that it's always there, and that the journey time is very predictable. It's a 5-minute trip, never gets stuck in traffic. The system is almost always up. It's 99.7% availability, which matches the kind of availability Robert was speaking about, and also matches the availability we've come to expect from airport automated people mover systems. So it's also a quiet and personal environment. You might share a ride with other people, but only a few. You get your prompts in different languages. You also can press a button and talk to controllers and get personal feedback and help. And people feel secure and safe in the system. Here's a visualization of the popularity of this system. The blue line is the occupancy of the car park for the year before the system was introduced. Immediately upon introduction of the system, they increased the rate for parking there by 20%. Nonetheless, within a year, the occupancy of the parking lot, as seen by the red line, had approximately doubled. So not only are people happy using it, but Heathrow is getting more revenue because they're charging more and more people are using it. Other benefits to Heathrow include that now people have a little more time in departures. Instead of getting to the airport a little later, they come to the airport at the same amount of time before their flight. But because the trip is quicker, they spend more time in departures and they're happier. So the impression is that they are spending more money. Also, Heathrow is generating revenue through sponsorships. So Marriott is paying for wraps on the vehicles, and you see an example of a wrapped vehicle on the right there. They also have a hotel that's located adjacent to the parking lot, and they installed a turnstile, and passengers or residents of the hotel can enter the parking lot through the turnstile and ride the PRT system at a charge of £5 per trip. And they're getting some 2,000 passengers a month that way, which is not an insignificant number. So finally, the system has removed many bus journeys, which reduces congestion and also reduces emissions. So what is Heathrow looking at next? Well, first of all, because the business parking lot has become so popular, they're looking to expand it, which will require the addition of some more vehicles. They're also looking for additional sponsorships. And then they're looking to put in a second system that ultimately would be connected to this system, but it would be a second standalone system in the central terminal area, serving the central terminal through tunnels under a runway. This was where the system was initially going to be installed, and then they changed their minds and installed it at Terminal 5 first. So those expansion plans are included in Heathrow's official budget. Unfortunately, the official budget had to be trimmed somewhat, and the expansion was one of the items that was trimmed from immediate implementation. So other opportunities that ULTra is looking at include Florianopolis in Brazil. This is a situation where the PRT is shown with an orange dashed line. There's also a monorail with a green line and a ferry with a dashed blue line. So this is a situation where you have multiple modes all serving different aspects of the transportation needs. This is a rendering from Florianopolis, and you can see PRT vehicles going into and out of a building in the rendering. ULTra has also been looking at potentials in Taiwan, namely in Linkou, and this is a rendering or a screen capture from a simulation of a system there. So now we're going to move on to Modutram. Unfortunately, for unknown reasons, Fernando Mijares has been unable to join us. We do have his slides, and I've asked Robert to go through them and tell you about them to the extent that he can. So Robert, over to you.
Yes, thank you, Peter, for this opportunity, because obviously, as speaking for my competitor, I'm going to use everything to trash the system now. No, I'm kidding. It's very unfortunate that Fernando is unable to join us, and I'll try my best to be the salesperson on this time on behalf of Modutram. Modutram basically started in 2010, developing the concept of, well, not PRT, but GRT in a sense, from Mexico. More of a track-based system. It bases itself on a cooperation with several Mexican research centers, and has actually realized a test track in Mexico at Guadalajara. And you can see some pictures of the facilities they have realized. And well, if there's any more questions on those, I'm banking on Peter answering those, because Peter has actually visited that application. The system is dubbed Autotran. You see that they have a higher cruise speed foreseen at 45 kilometers per hour. It is a battery operated system with a range of approximately 38 kilometers. They are looking at 6 persons per vehicle maximum occupancy, and all people are to be transported seated, so there will be no standees. The capacity that they can achieve on a single line is approximately 4,500 people per hour per direction. The latest body design is the one that is shown in the picture on the left, and they have a state-of-the-art electric drivetrain underneath the vehicle, and you can see it's a rubber-tired vehicle as well. These are some of the guideway structures that they're showing. It's been designed to be able to cope with seismic areas, so they can also install it in areas where, well, earthquakes are typical. As many vendors were looking into station designs and how to create a station design that is most economical in space. And here you see the suggestion from Modutram with a multimodal integration and inline berths. And especially the multiple berths in parallel is a good feature to have, because when you're transporting 4,500 people per hour, you need to have sufficient berths to actually accommodate those passengers coming to a station. Well, obviously this is some explanation on the simulation tool and the emulator tool. want to make very clear that where there's often confusion about is that there's a big difference between simulation and emulation. The video that I just showed you about the operations in Hsinchu is obviously a simulation, because you'll never see a vehicle in real life take a roundabout that quickly and that fast. An emulation system actually how do you say it, mimics the actual operating system and the actual vehicle behavior to result in a copy of the actual operations and what can be expected as closely as possible. A little bit more description on the test track. You can see some data here of what has actually been realized, and that they're able to do quite a steep incline at 15%, and that the track also has super elevation included. So Modutram with this test track is well positioned to show the various realizations of the infrastructure that can be encountered during applications. Their commercial status, and obviously I would have liked them to be much clearer on this to see where they are pursuing opportunities, but as their smart move is, they are being conservative about this, and I think that in due time, when they do enter into a contract or a project, there's certainly going to be more clarity about this. With that,
thanks,
try
Robert.
to give you an impression of what they are doing over in Mexico. I would like to open the floor for any questions, and Peter and I will do our very best to answer any questions that there are left. You can.
Thanks, Robert. I would like to add something about Modutram that is very interesting, and that is that their system is called AutoTrain, which means car train, and they're proposing, as you might have picked up in some of the renderings, to roll out a system that's capable of platooned operations with two vehicles connected together. So this more or less doubles their potential capacity. As Robert said, we welcome questions, and go ahead and type them in the chat box, and we'll try to get them answered as effectively as we can. Also, please be aware that this webinar and previous webinars will be posted on the ATRA website, so that you or people you're interested in looking at them can view them after the fact. Thank you very much for attending.
I see Scott's question first, and then I'll tackle Sven's question next. You're saying, can you contrast your system to a SkyTrain system that's being constructed in Tel Aviv? I think what's happening now in the market is that the term PRT, Personal Rapid Transit, is actually how do you say that, a holder name for many different systems. And the technologies that are being used to realize PRT systems are greatly different, where SkyTran is a system that is not focused on the last mile. So it's not a feeder system, but it's rather an all-encompassing system, also designed to allow people to travel over longer distances. Our system is much more of a feeder system, with the maximum speeds being much more limited. In that sense, I'm not even sure whether SkyTran and ourselves would or could be seen as competitors. There would be very few applications where a system with such a high speed as SkyTran features and such a limited maximum speed as we feature would be directly competing with each other. And I believe there's a market for both. The question becomes, how quickly does a market develop, and is it sustainable for the long term? And obviously the two companies have different visions on this. So we'll see whose vision is right or wrong. Maybe they're both right. With regards to Sven's question, is there any extension plan for the Masdar system? Well, there was a very extensive system planned for Masdar. That's been scaled back a bit because of the crisis. Masdar is now developing its site in a different way than was originally foreseen. I know that the people at Masdar are comfortable with the PRT system and the abilities that it has, and I know that within the transportation plans for the future that they're looking at, PRT is still being considered. Whether or not it will actually be extended or not is a question that I can't answer at this time, but that we need to reach out to somebody that's involved within Masdar to give us an indication. At least no official decision on extensions has been taken yet.
Thanks, Robert. Thanks, Robert. Fernando has just managed to join us, so if anybody has any questions about the Modutram system, he's now available to answer those questions. I see there was a question about when the SkyTran track is due to open, and Brian, we don't have any information specifically on SkyTran. There's been quite a lot published, and I recommend you go back through the ATRA Pulse newsletters, which are also available on the website, to see what they've been publishing about their system.
Peter, you want to go back and forward answering all the questions, because there's one of Lloyd that I would like to take, but then let's see who does what.
Yes, why don't you do Lloyd's question?
Yes. Lloyd, my experience is that this greatly depends on the location where we're actually realizing the system. If you look, for instance, the application that we have in the Netherlands and the application that we have at Masdar, in the Netherlands there's nobody at the station, and the system should just run itself, and they have what they call flying controls, which means that every once in a while there will be conductors checking or not whether people have paid for their ticket. If there is a spill inside the vehicle, there's actually, the supervisor is quite close, he can see it on his cameras and he will come in quickly and clean it up, but it's not very actively monitored. If you look in towards applications in the Middle East, that's a much more serious concern, and typically they want to have a station representative at stations, they want to have a security guard at stations, they want to have people involved in the ticketing to assist people in getting their tickets. So cleaning of pods, either you have a dedicated resource at station for accidental spills inside the vehicles and to maintain the cleanliness of the station as a whole, or alternatively you combine different functions at the station. We usually recommend that if people want a station representative and a security guard, that those roles be combined into a single person to minimize the manpower required at stations. And I'll pick up Walt's question while I'm on it. Yes, we do foresee passing through stations. So we'll only stop at stations if passengers inside the vehicle have indicated that that station is a destination where they need to get out, or alternatively, when there's a passenger at the station that has designated that he wants to be picked up. Otherwise, we'll just connect through, and thus our frequency or our transportation time will go down. Scott's question, before I leave Archie's question to Peter, because Peter is really well aware of that. Does the US require a certification process? Yes, any country will. At this time, the debate is a little bit difficult, as the APM requirements, which are made by the American Society of Civil Engineers, are usually referred to as a standard. They're guidelines. They can be adopted as standard by certain governments, but even when they are adopted, they're most of the time not specifically written for the smaller scale systems like you see them here, which doesn't mean that the smaller scale systems shouldn't meet those requirements from the APM standards that are applicable to them. In Europe, you have a different set of standards that you would also need to meet. And what you see is in the Middle East, they usually refer to the standards that are available either in the US or in Europe that you need to comply with. What we have done in the past, and what's a requirement or becoming a requirement now in multiple countries, is a process that uses an independent safety assessor. So it requires the supplier to set up a design safety case. It requires the operator to set up an operation safety case. And it also means that the independent safety assessor will look at your calculations of how you actually reach the safety target that has been set. For the Masdar application, we've gone through a process with an independent safety assessor, which was Lloyd's Rail Register, and we've gone through an assessment by an independent health assessment, which was Bureau Veritas. And the questions ranged widely, and some questions might seem trivial, while other questions actually have a big impact on your system. And in terms of the health assessment, those included questions on you're using a touchscreen inside the vehicle, somebody that has a cold comes into to the vehicle, sneezes on the screen, the next person who comes in, what's the chances of him also catching that cold? And while that one might seem a little bit trivial, a person that's actually sick inside the vehicle and we are, for our climate within the vehicle and our battery operated vehicle, we would like to recycle as much of the cool air inside the vehicle that has already been built up, because recycling cold air is more energy efficient. But if there's a virus in that air, it actually recycles the virus continuously throughout the system. So the percentage of fresh air that you actually take into your air conditioning system and actively cool becomes a very important discussion, where we, from an energy efficiency standpoint, would like to minimize that amount. Obviously, for healthcare reasons, you don't want to do that. So it becomes a very careful consideration, and it can have a very big impact on your system. And these are discussions that with an independent safety assessor and independent health assessor, you are continuously going to have. Peter, to you at airports.
Yeah, Archie, thanks for this question. It's an excellent question. I used to think that the market for PRT at airports in the US was maybe the top 10 biggest airports. But we recently did a study at Greenville Spartanburg Airport, which is about number 100 in terms of passenger carried. It's a small airport. And we did a life cycle comparison between a shuttle bus system or a PRT system to serve their existing and proposed parking lots. And we're quite surprised to find out that the costs were almost the same. The PRT life cycle costs were actually slightly lower than the bus alternative. And the airport loved the idea of the PRT because it didn't add to curbside congestion, which is an issue for them. So I now believe that the market for PRT at US airports is some portion of the top 100. So maybe there are 50 airports in the US that are suitable for PRT operations. And it can certainly serve parking lots, but then it can go on to serve as a transportation system between terminals and concourses, within concourses. The opportunities are great. In fact, we've been involved in a number of situations where we've done quite detailed comparative analyses, including simulations and cost estimates and so on, between personal rapid transit and automated people movers at airports. And we seem to quite consistently find that personal rapid transit has the ability to move the same number of passengers for costs that are in the order of a quarter to a half of the cost of an automated people mover. In terms of capital costs, the operating costs are probably more in the order of 70 to 80% of the people mover operating costs. So overall, much more cost-effective system that actually provides a higher level of service too, because you're able to have more stations with shorter walking distances, and you're also able to have everybody be seated. So with that, let's see, I think I'm going to hand it back to Robert, and he can answer Scott's questions. Oh, I'll pick up Sven's question while I have the microphone. The timescale for the Heathrow pod extension was going to be in the next few years when the initial budget came out. But then, as I said, they had budget cuts, and the PRT system got cut out of the budget. So we don't know the timing for a expansion at Heathrow. So Robert, back to you.
We're making this into a tennis match, aren't we? I think, Scott, I already answered your question in the chat, so I hope that answer is sufficient, allowing me to address Walter's question now. The guidance system that we are using is basically a guidance system that was developed back in 1984-85. At that time, we were an industrial automation company. We had a customer reach out to us that had Stelcom plates, which are the concrete plates with the steel rims around it, and they wanted to drive automated guided vehicles outdoors. And because these Stelcom plates move relative to each other, and they would break the steel wires, and the steel wires would have to go through the rims of these plates, they were looking for an alternative method. And at that time, one of our engineers came up with the idea of free ranging on grid. And Frog, that's the original company that we are a spin-out company of. And basically the thought is you can drive any route you want to as long as you encounter a reference point every once in a while, which allows you to correct your position relative to the position where you calculated you were at. So what we do is we measure our lateral position by means of a gyro, knowing in which direction we drive. And we measure how far we drive in a certain direction by calculating the number of wheel revolutions, odometry. And this gives you a pretty accurate estimate of the location you are actually at, because in practice, without reference, we are still with a minimum deviation over 100 meters. But what we do just to make sure that we're absolutely in the correct position is we embed a magnet in the road surface every 2 to 4 meters. At Masdar it's every 2 meters. At Rivium it's every 4 meters. And every time we drive over a magnet, we measure the position of that magnet. And we compare that to the actual position that's located in the database of the vehicle. And with that system and with correcting any deviations that there are relative to the magnet, we are able to drive within 2 centimeters accuracy, so 1 inch, on the straight sections of the track up to a speed of 80 kilometers per hour. So this has all been tested up to those speeds, which means that in fact, yes, we can use an existing infrastructure, which we've done in the south of France, in the city of Antibes, where we realized a demonstration for 2 weeks by closing down 1 lane of the street and actually having the automated system run up and down that street. At the same time, we are a manufacturer of automated people movers, or if you will, automated guided vehicles. We are looking into what we can do in terms of reducing the amount of segregation that's required for the system to operate. We are not looking to be the next company that produces a competitor to the Google car. I hope that answers your question.
Fernando, could you enable your microphone and answer some of the questions that have been directed Modutram?
Yes. Hello? Yes, of course, Peter. Thanks for the question. Well, about the Cuernavaca project, there is we have signed an agreement with the government in order for them to follow up the technology development. This is they are aware that this is a technology that is on development. So what they want to do is to follow up all the steps that we are going through in order to have a system that will be ready for them. So what we have done is a study on how to integrate our system with a bus rapid transit corridor in a part where the bus cannot go through because there's no more space. So we've done that. We have also presented the last body with the urban body for the six passengers that are seated. It will be for the urban applications, and they are happy with that. So what real now in our current status, let's say, is that also we have to show now the next step on our development, and that will be a complete test track with a station, with a passenger station added here, and more vehicles in order to demonstrate that the system will be ready for them. Also, right now, there is a electoral or political time where we have to wait a little bit more. But after that, the next step will be to demonstrate here in our test track and then continue with the project with them.
Thanks, Fernando. There are a couple of suggestions that your speakers may need to be turned off. There was quite a bit of echoing in your presentation. Somebody asked about automated cars and if they're a threat or an opportunity. And they're kind of both. They are certainly an opportunity in that there's a lot of technology that we're developing that they can use, and vice versa. They're a threat in that some people seem to think that automated cars are going to solve everything, and therefore you don't need any other form of transportation. I'm a skeptic in that regard. I think automated cars are likely to quite quickly have an impact on accidents, which will be fantastic. But I don't think they're going to have an impact, a positive impact on congestion. In fact, I think there's quite a strong likelihood that they could increase congestion before they do anything to relieve it. And I think it's going to be 20 or 40 years before they start to relieve congestion. So I think automated cars are not really a threat. And I also think that in some ways they make life easier for us because whereas people used to be skeptical about the PRT technology being able to work, now they accept that cars are going to be automated. And when they look at PRT, they say, oh, well, that's a no-brainer. It should be much easier to automate a PRT system. So if cars can do it, PRT must be able to do it. So in some ways, all the talk of automated cars has removed this concern about the PRT technology being able to function. So with that, I think, Fernando, there were a couple more questions for you. I had one regarding how are your vehicles coupled? Are they physically coupled or is it enabling? And then with, does the coupling occur in stations and can they decouple on the fly? In other words, can a pair of vehicles leave a station and then somewhere in the journey split apart and go to two separate destinations? Thanks, Fernando.
Okay, Peter, our coupling is still on development, but the first objective for that is to have a mechanical coupling in the stations. Then, as a second stage, but that will be more to the future, we will be pursuing this, as you call it, on-flying coupling. But for the first stage, let's say, of that development, that will be to have a mechanical coupling being done in the stations.
If nobody's talking at this moment, I would like to take the opportunity to get back to the question also, Sven, about the autonomous cars. The autonomous car definitely has a place, and I mean the companies that are pursuing it are doing well very seriously. So the development is absolutely ongoing. But I think if you look back on cities around the world and which cities function properly and which cities are dysfunctional, you'll find that the cities that are typically lacking a public transportation system are now introducing those systems in hindsight. And I'm specifically looking towards cities in the Middle East that include Riyadh, which is introducing an extensive metro system, which includes Dubai, that has included or introduced a metro system, and Abu Dhabi, who is considering such a new tram system coming up in Dubai, new types of systems like these being realized in Qatar. So all these car-oriented societies are introducing public transportation because they see the two systems needing to exist in parallel. So I don't believe you're ever going to see a city that's solely based on a car, whether it's a manually driven car or a autonomous driven car. That combination is essential for the future, and I think the two are going to coexist, and otherwise I wouldn't be in this line of business, so of course I'm of that opinion. And what you'll see developing over the next couple of years is the systems like these either being a feeder to larger scale networks or car sharing coming with autonomous cars. That's a development that I'm interested in. If you look at the autonomous car, it will reduce the number of accidents. It might or might not reduce the congestion. What it won't do, unless you go for car sharing, is reduce the actual amount of cars inside a city. And if you're looking at it from a sustainability perspective, this means that the parking issue that is perhaps a more serious issue even than the congestion within our cities is not being addressed. So much space is wasted within cities on parking, and if that's not addressed, we are not approaching sustainability in its true form. So car sharing would allow for that to do, but if you introduce car sharing, it also means that the automated vehicles who have been left after completion of their journey should be made available to the next person to use. And the next person to use might not be located at the same facility where the car was dropped off. So it also needs the development of a supervisory system, if you will, to actually ensure the empty vehicle movement of those shared vehicles from one point to the other. And that's the system element, or that's what makes something a system rather than just an individual product, which has not been addressed yet, which is not present in all the automation efforts that are being undertaken with regards to the autonomous car. So it's a very interesting development, and I think you'll see a lot of parallels between the two, and I think you'll also see that people are completely focused on their own development and not seeing the purpose or not wanting to see the purpose of the development happening adjacent to them.
Well, are there any more questions? One thing I would ask is that if you didn't already do so, please enter the city and country that you're located in so that we have a better idea of the geographic spread of the attendees. I see some people are typing, so we'll hang on and answer their questions or get their input. Yes, Walt, I take your point that automated cars do have a number of advantages in providing single vehicle doorstop service. They also have the advantage of using the existing infrastructure and the advantage of being acquired by individuals rather than agencies. So they have numerous advantages over transit technologies. And I think this is actually an issue that we need to try to level the playing field, because even though they have all these advantages, they may not solve the congestion problems that we so desperately need to solve. And so we need to do something to level the playing field, to give transit, automated and advanced transit, an opportunity. Robert, you want to answer Kevin's question?
Yes, of course. Well, the magnets, it's a simple question actually. The magnets can be missed. We define the amount of magnets that are allowed to be missed. So what we have is a patent on a magnet measurement system, which is located underneath the vehicle, which is able to precisely identify the position of the magnet. Typically what we do is we know our deviation isn't large, even when we miss the magnet. So if there is a magnet every 2 meters, we usually allow it to miss 1 or 2 magnets. When we miss the magnet, it is entered into the database that the magnet has been missed. Should the same magnet be missed more often and by different vehicles, it's an indication that the magnet might have been damaged or something might have happened to it. This was especially the case with the first generation magnets that we had that were non-coated, and if they were chipped a little bit, the water seeping through the pavement would actually allow the magnet to become corroded and the magnet to go dead. Since that time we have been using a coating on the magnets, and we have not experienced magnets going dead again unless somebody on purpose grabs a drill, drills into the asphalt and breaks the magnet. We do allow magnets to be missed, but typically this doesn't create a problem with the system unless there's a range of magnets in a row being missed. We actually use, the individual magnets are not recognizable, so they just provide a signal, so we match them to the location where we are. The one thing that we do at specific sections in the track, we use the magnets with a north-south poling to create a code, and the code actually matches with a specific section of the track. So that also means that when we get new vehicles into an application, we can download the map of the operations area inside the vehicle, and all we need to do is drive them over a code, and this will light up a button inside the vehicle which will show that the vehicle knows its position relative to the map, and at that time we can switch it from manual mode to automatic mode, allowing the vehicle to enter into service like any of the other vehicles that were previously operational there.
Well, our hour is up. I thank you all for attending. This has been a fascinating discussion. I hope you've all enjoyed it and maybe learned something. Thanks for contributing to it. We appreciate it. As I said, this will be posted on the ATRA website for later viewing. And once again, thanks everybody for your attendance and your interest.